All right, let's get started. Hello, everyone. Welcome to the MIT Mobility Forum, session 158, discussing carbon impact of a workday. Since COVID, many of us are working from home. And on average in the United States, about 30% workday on average across the board are happening at the non-office space. So does working from home reduce CO2 emission? I think for most people, the intuition says yes, right? I don't need to commute. But in reality, not necessarily. There are two main factors that may influence this. One is the commuting travel versus the total travel. Two is the commuting energy consumption versus the home and office energy consumption. So we really have to examine the whole system. The second part is today's focus. Look at the commuting, space use of office and home, energy efficiency, building technology. So join us today are Jacob Plotkin and Rives Taylor and Bhuvan Atluri, who will present a joint research between MIT Mobility Initiative and the Gensler Research Institute. Before I give the forum, let me do two warm-up polls from the audience to give some background here. Let me try to start that. So the first question, let me launch, is ask people's intuition on the following. If you look at your square footage per person in the space, in the office, talking about the desk worker, versus the single family home space square footage at home, what's the ratio on average across the United States? The 90 people responded. Let me give you a few more seconds. Okay, so I'll close the poll. We have 138. It's 139, 140. Okay, let me close and share the result. Oh, wow, it's quite evenly distributed here. So 10% 1 to 1, 1 to 1, 1 to 2, 1 to 4, 1 to 6, 1 to 8, 1 to 10. So I will leave the answer to Jacob to tell people the empirical data on this. Right? Okay, the first one. All right, the second one question is, let me open this again, back. Is when you leave home for the day to go to work, go to the hospital, go to wherever, leaving home, right? What do you do to set back all different devices? Lights, fans, exhaust, purifiers, heating, cooling, connected devices, all the charging stuff, your TV, smart TV, so, or everything. It's a multiple choice. You can choose it. This question turns out to be an important factor that may influence the actual CO2 emission, as you can imagine. Okay, 150 people participated. Let me just give 3 more seconds. All right, so end the poll and share it. All right, 92% lights, 57 fans, about half to heating and cooling, only 10% to devices, and 7% to everything. Great, yeah. So Jacob, please, in 30 seconds, give people the take-home message.
Absolutely. Hi, everyone. Jacob Plotkin, New York City, Gensler Research Institute. So our research today looks at the carbon impact of a single workday across a big selection of U.S. cities. This includes commuting, the energy used in homes, the energy used in offices. And we found that the systems that are driving the emissions variance between these different cities are largely top-down things. Things like energy grids, building codes, urban form, transit availability. And we can make a big change there with design and policy, but all of these things change really, really slowly. But behavior, on the other hand, behavior we can change today. And choices like your commute mode, your commute distance, how much space you occupy, whether you power down your homes during the day, like we're seeing on this poll right now, all of these have a measurable impact on your emissions today. So we're seeing this dual timeline of decarbonization, one that's long-term and structural, and one that's short-term and behavioral. And both really matter when you're reducing that carbon impact of work.
Wonderful. Thank you, Jacob. I will invite John to give a bit context of the project. John, please.
Yeah, I just want to say a word about the genesis of this collaboration between the MIT Mobility Initiative and Gensler. I think many of you know Gensler is the world's largest architectural and design firm. And the work that we're about to present starts with a conversation that we had with Diane Hoskins, who is their, at the time, their co-CEO and currently the co-chairman. And Diane had a vision about asking a question that really was at the cusp of two adjacent systems, the transportation system and the built environment. And as Gensler was joining our program as a member company, we realized we really needed these kind of two pools of expertise to collaborate together. And I just, I want to thank Rives, Jacob, Tim, everyone from Gensler who's worked on this over the past, year and a half plus. I think we've come up with some very interesting findings, number one, which you're about to see. But number two, I think we've also exposed a sort of new model of collaboration that we at the MIT Mobility Initiative are very happy to embrace in working with our member companies, with research organizations within those companies to do some work together. So we're already seeing the fruits of building on this model with some other of our members, and we welcome more suggestions for this type of collaboration. So with that, thanks to the team at Gensler, and I'll turn it over to Rives.
Great. Well, again, thank you all. I'm Rives Taylor. I'm in Houston, Texas, where the commute is a killer. I run the Research Institute's Resilience Focus, which is really all the umbrella around sustainability, engineered resilience, regeneration, well-being, etc. And this was one of the several IP-focused elements that if you were to go to our website, gensler.com, and look under research, we really do focus globally on this interface of research with design and having occasionally the terrific partnerships like we've had with John and Bhuvan at the Mobility Institute. And again, we're very interested in the sidebar chats are exactly the thinking we want to get started. Jacob, if we go to the next one, I'm just going to introduce, but Jacob is going to be the fast runner. As I said, we are a design firm, but really for the last 20 years, it's been backed by a lot of research. We are a research design firm. Our drive for both success in what are 34 different kinds of project types, from airports and hospitals and hotels to workplace to mobility, et cetera, really are driven by the concept of we don't start from scratch. We really do have a belief in the institutional memory of research and looking at where things are going and asking questions that tie together multiple disciplines and multiple approaches versus the same old, same old. Go to the next slide, Jacob, if you would. So historically, we have been actually in the business for just about 10 years, where we've been reporting our own efforts to tackle climate change, to look at the carbon footprint of our projects. We were part of the original COP21 in Paris, one of the few design groups there saying we need to focus on the design of our buildings and communities to really understand the implication of our own practice, but our impact. As a very large firm, annually, we report out what our projects do in terms of energy use and water use. You see at the bottom kind of the covers of publications that are accessible on the Gensler.com website. Impact by Design is the most recent one. Resilience by Design is kind of an evolution. We've also partnered with a lot of survey work, looking at the implications of cities and carbon, and cities and climate change or weather challenged aspects, and looking at the implication of livability, mobility, as well as personal experience. You tend to live in a place, love a place that you're connected to and supports your family needs, etc. This idea of the carbon footprint of workplace, as John noted, came about with a fairly simple approach, which is, as designers, how might we better design the places we work, whether it's home, the third place, the office place, etc. And it evolved quickly into thinking more particularly understanding the lay of the land, which Jacob is going to talk about right now. Again, colleague Jacob and I have been working on it for a while with a number of thinkers internally, and we really had an amazing partnership to look at the commute. And again, Bhuvan and John asked some questions we hadn't asked about even the built environment. So the collaboration was much appreciated. With that, Jacob, go ahead.
Thank you so much, Rives. So why are we even talking about this today? Well, a third of the US population, working population, has jobs that can take place in an office environment. This is a massive market right here that we're talking about, a large swath of people that have the potential to reduce their carbon footprint. And particularly, as I noted during the short elevator pitch earlier, these choices of where to work and how to commute have really significant impacts on carbon emissions. Now we can look at that globally. We can see here that building operations and transportation make up about half of global carbon emissions. Now, of course, this is all types of transportation. This is also bringing goods from place to place, but this is the commuting element is baked into this, as are our homes and the office buildings that we work in. And it's that homes element that we really want to enter into this report. We are not the first people to look into the carbon impact of work, but we are the first ones to do as deep of an insight into this. One of the big changes that we made here was looking at residential space as well. Residential space is the majority of the built environment in our cities. And importantly, when we go to the office and we work in the office, our homes don't disappear. They still are using energy. They still have carbon emissions. And that's why, as we used during that poll right there, we are trying to reduce emissions at home at the same time. Now, how are we doing this? It's a very simple calculation with a lot of methodology that goes into the back end. It's your home emissions plus two-way commute plus the office. It's a very simple equation there. And the way it actually pans out from what we were looking at, it was an 8-hour workday with 2 1-hour commutes on each side. If you're working from home, of course, those commutes are nullified. Otherwise, that's 8 hours in the office with 2 different commutes. So we can go into the methodology end of the homes and offices, and then I'll be passing it to Bhuvan and John to talk about the methodology behind the commute. So first, we have to know that energy use is not the same everywhere. If you are in a colder climate, you will be using more energy to operate your building. And that's because heating is much more energy intensive than cooling. So operating 1 square foot of space in Chicago, much more carbon intensive or energy intensive than operating that space in Los Angeles. And also, we know that carbon intensity is very different depending on where you are. Every city is powered by a different sort of energy grid. If you're in Chicago, you're using a lot of coal to fuel your home. If you're in Los Angeles or San Francisco, it's a lot of renewable energies going into operating that space. So we're seeing a massive variance in carbon intensity between these different locations. And importantly also, this is not just a question of carbon intensity, but that's carbon intensity per square foot. So every square foot of space that you operate, you are using more lighting, you're using more heating, more cooling, which means that if you're in an office, you're occupying a much smaller square footage of space with much less needing to be occupied versus a multifamily home and then a single family home where you're seeing much more occupancy, much higher square footage occupied per person, which means a greater amount of conditioning, greater amount of lighting, et cetera, per person. So because of this, we are seeing that single family homes are more carbon intensive than multifamily homes. You can see the single family homes in the dark blue there. This is primarily because these are places where you're occupying more square feet per person. This is per person per year right here. And you can see that compared to the office. Now, of course, the office doesn't delete the other 2 components. You still have your home when you go into the office. But the office on a per person scale, because you are so densely packed compared to a home, is a much more carbon efficient place to work. But of course, as I mentioned, those homes don't disappear when we go into the office. So what's the solution? We can reduce our energy use at our homes during the workday to better leverage that added efficiency from working at the office. And the goal is to have this energy reduction offset the greater energy used by commuting. So we can see here these 2 different setbacks that we're looking at. We devise these a mild setback of 30% reduction in your home energy use. This is achieved by reducing your HVAC burden, setting it to 80 degrees Fahrenheit for cooling or 67 degrees Fahrenheit for heating. And then we also have an aggressive setback, and this takes you down 60% by turning your HVAC totally off, turning your lighting off, reducing plug loads, putting your appliances on standby, everything you saw in that fun poll earlier. But of course, not every person everywhere can do this. You can imagine you might have a pet that stays at home. You might have an older relative who lives at home. You might have anybody who's still at home, which means you might not be able to turn off your HVAC, especially in those cold Boston months. But we found that about close to half of people can comfortably take these aggressive setbacks during the workday. And this is based on separate research we did called the City Pulse, where we surveyed people and how they were living in cities across America. Now, here's what that actually looks like, that setback. This is a 60% reduction in energy use. And you can see here, it just completely drops down from that single family right there. And this, in many cases, can offset that added emissions burden of the commute. And that is our goal here, of course, if you're going to use the office to have that large aggressive setback. But it's not just the home that can be set back, it's also the office. If anyone tuned in early and heard me and Jinhua talking, the offices can be set back as well. When people are not in the office, and importantly, this is when everyone's not in the office, or if you have a modular system where in one floor of the office, one section of the office, people are not around, you can also do an office setback. Say we have people work 3 days in the office, 2 days at home. During those 2 days at home, you can perform this setback of about 50% reduction in office emissions. And like I said here, can only be done when there is an entire unoccupancy. People are out of the office. This is an organizational decision. This is something that has to happen at the office manager level. This is not an individual decision like the home setback. And here's what that looks like. You can see here that 50% setback is chopping away at those office emissions. And with that, I'll pass it over to Bhuvan to take on the commute side of things.
Okay, so I mean, all this shouldn't come as a surprise to a lot of our audiences, who a lot of them are transportation planners, urban planners. But if you go to the next slide, it's obvious that most of the folks in the US commute driving alone in single occupancy vehicles to work. A few carpool, but this number has been trending downwards actually. Very few use public transit. There's a larger number that has been working from home since COVID, but that has again stabilized to around 28-29% of worked hours in a week, and a very few percentage cycle. But again, averages are not something we should go by, because there are extreme variations across cities, which we see in the next slide. If you look, Jacob, the next slide. Yeah, I think there's a lag. Anyway, so yeah, so New York City, San Francisco, Chicago, and I mean, we have Boston as well, which have more than 25%, 20-25%, New York being the highest, close to 60% using public transit, and high other modes of walking and biking as well. And if we move to the next slide, this again, the switching from a gas car to public transit, Jacob mentioned this in the 30-second summary. The emission impact is quite high, not a surprise, and it's just amount of fuel being used per mile. Which we've sort of outlined in the next slide. A gas car consumes around, emits around 400 grams of CO2 per mile, and this is just going by the average fuel efficiency in the US of 22.3 miles per gallon. A hybrid, it will be slightly higher, and EVs is lower. It's around 144 if you go by the 2.8 miles per kilowatt hour, and the grid carbon intensity average for the US. Now, public transit, this is a huge argument. What is the carbon intensity per mile per passenger for public transit? The figures will vary depending on which city you are. What's your mix of light rail, heavy rail, buses? Do you have electric buses, hybrid buses, regular diesel buses? What's the average passenger occupancy? So we went down that rabbit hole quite a bit, used figures from OECD, the International Transport Forum, looked at a variety of mixes, and we took a slightly higher estimate of close to 90, 93, close to 100. In many cases, it comes down below 50 in Europe, but we know the US public transit agencies, they may be slightly higher, and not the occupancy rates may not be as high as Europe. So we went with 93. And for bike share, some of you might be surprised, hey, isn't biking like zero carbon? Well, I mean, biking sort of is, but there's a lot of rebalancing of the bikes that happens that use vans to go around the city, and that's the figure that you see here. And this is all operational carbon. We are not looking at the embodied carbon of manufacturing the vehicle, and this is the system. So we're just looking at operational carbon in this whole research. And for biking and walking, we've effectively taken it as zero. One can make an argument that, hey, you might eat more if you bike and walk a lot, but we've said let's keep that aside for now. So if you move to the next slide. Again, longer commutes are more likely to be taken by a car. This comes down to the point of, as if up to 5 miles you're comfortable cycling, maybe an e-bike up to 8 miles for a commute, but after that it really tapers down. And we see this like across the 9 cities that we looked at for commute modes. And just to clarify, we used a lot of data from the US Census Bureau for trips composition from the EPA. And we used a lot of replica data for this, the mode share split between cities. And as cities get less dense, people start commuting more, and obviously this commute is taken more by the car. The share of the car goes up from less than 20% for New York to above 70% for the less dense cities of, say, Denver, Miami, Houston, and Phoenix. And this comes back to the point of densities in the next slide, where the commute distances are shorter in transit-rich cities because these are denser cities. There's more transit-oriented development around these stations. A lot of people live there and can commute there. And we'll sort of bring all this together in the section where we combine transit, home, and residence. So yeah, and the last slide before we go to the scenario analysis of calculating the whole workday carbon is for walking and biking, the active modes. So Jacob, if you can go to the last slide. Yeah, so walking and biking is inversely correlated with car commutes in all cities. Not a surprise if you just look at the previous slide. More density, shorter commutes, people will choose the more active modes. So your older cities of New York, San Francisco, Boston, see more people walking and biking and lesser people taking car trips. And I personally have seen, the increase in bike lanes in Boston and Cambridge has really pushed the number of bikers commuting day in and day out. So I'll pass it back to Jacob to sort of get everything together and discuss a couple of scenarios.
Thank you, Bhuvan. Right, so we've got our homes, we've got our offices, and we've got our commute. It's time to put that all together. And you can see again, here's our calculation of how we're going to simply add that all into one big bucket. Now, of course, it must be noted that not everyone has the same schedule and the same way of going about things. So we've come up with a few different scenarios right here. We're just showing off for this presentation. The first is someone who works from the office with no home setback. We call this our all-on everywhere approach. This is you are not turning your lights off at home, you're not changing your HVAC, you are commuting, and that office is fully operational. So of course, this is going to be a higher emissions. You can think this is someone who does not, make the intentional effort to reduce their emissions during the workday. Second option there is someone who works from the office with that mild home setback, that change of the HVAC depending on the heating and cooling for the seasons. Third, being working from the office with an aggressive home setback, that's fully turning your HVAC off, fully turning your lights off, reducing your plug loads, putting appliances on standby. And then finally, number 4, that work from home, having no office setback. People are still working in the office, but of course you eliminate the commute there. Now we can look at this by city. You can see those different scenarios that we just parsed out there. We start with the aggressive home setback, then the mild no home setback, and then working from home on the other side. Now, in a place like Chicago, and this is going to be important to note how these shift between different cities. A place like Chicago has a very dirty grid. It's coal-oriented, and it has a very cold climate, which means more heating, which means more carbon emissions. But it's also a very dense city, which means that it's somewhere people are taking a lot of public transit comparatively to other cities in the US. So for a place like Chicago, we can see that you're reducing emissions by moving to the left-hand side of this chart, by aggressively setting back your home, by reducing those operational emissions of space, because it is from the space where these higher emissions are coming from. And we can see a very similar thing in New York, but with smaller numbers. Of course, New York doesn't have quite as dirty as great as Chicago, still a cold city, still a dense city. So we're seeing that in a place like New York, moving towards that left side of the chart, having a more aggressive home setback and reducing the carbon impact of space is where you're reducing most emissions. And of course, you can also note that as you go down the list, you are reducing emissions by choosing to walk. But of course, the large gaps in emissions are coming from that left to right. And of course, multifamily versus single family. In a place like New York, multifamily is much more common. That's much greater reduction than versus the single family home. Now we have a bit of a different story in a place like Houston. Houston is a warmer climate. I'm seeing Rives, but Houston is a place where the carbon emission burden does not necessarily come from space. It largely comes from the commute. So you can see that instead, it's coming down the chart here, where we're really reducing those emissions, switching from that private car, going to public transit or walking. Houston's a very sprawling city. It's a place with longer distances, longer commute times, as Bhuvan showed on that chart over there. So really reducing the emission of that, the burden of that commute is paramount. Now in San Francisco, the story gets a little interesting because now we have a great amount of density as well as a very clean grid. So here you could take sort of a hybrid approach, reducing your commute burden to taking electric vehicles or public transit, reducing your carbon emissions via your space. But you can imagine, compared to Chicago, the actual variances in what you can decrease if you're taking that 50% from here versus 50% from the very high Chicago number. It's a bit of a less variance, but there is still carbon reductions to be made in San Francisco. And in Los Angeles, much like Houston, this is a commute story. Los Angeles is a driving city, and you can see here just how much of a massive drop you get in emissions by moving from your private car commute mode to those other commute modes. And Los Angeles is a very interesting case because of this very clean grid that LA has. Switching to that electric vehicle is likely the best option for a lot of people. In a place where there's not transit access and where driving is more common, if you go to electric, you are slashing your emissions by more than half in a place like Los Angeles because of this clean grid, without even considering reducing your carbon emissions of space via energy setbacks. So we've seen all the cities, but we want to bring out some broad overarching takeaways for design and policy that we can take from this. And for that, I'll push it over to Rives Taylor.
I can't help but just really enjoy the chat. I've been mesmerized by the response from our learned audience. And again, we're speaking to folks who have given this some thought, and even from, shooting fast from the hip, as they say in Texas. These are great observations. As you've noted, it really is about behavior. People on this call really think differently about different opportunities. I'm at home, but I still turn the system down when I'm by myself. What a great example. Or the idea too of just now the work from home. Why do we need offices? Well, we're in the business of designing high performance offices, and we see more corporations, in fact, bringing people back. And yes, the great debate, because there's a lot more productivity, a lot more community, a lot more cultural sharing. I mean, we're not arguing that because we're kind of in that business. However, it does make an important point that, the fact that over half of what we use our vehicles for does not necessarily connect to commute. Doing some research, we found in certain cities, the commute didn't exist to go to work during COVID, but we were still driving like crazy. So these are the sort of things we're trying to pull together as designers in working with the cities and the corporations to encourage a better set of choices. So Jacob, if you go to the first element, so kind of the key takeaway, there's things we can't control. There's things perhaps we can advocate for, but the reality is that the infrastructure supporting the larger system of our work and our commute is a bigger investment, a longer term investment. And therefore, what are the things we can do short term? We've already talked about, making choices where you live. Maybe you don't have the choice because of affordability, but the scale, obviously. We call this the advantage or the value of scale. Working in an office and collaborating shares resources better. Clearly, your business, public transit, is better. Even the multifamily approach, you may have the same square footage in a very large apartment, but because of the efficiency of operations, the way that the envelope is maintained, there's a lot of things in our business. We see that even multifamily, large scale apartments, same size, there's still an advantage looking at the analysis we did with our energy modeling. And again, behind this is a lot of energy modeling based on CBEX, based on DOE and ASHRAE. So, a lot of understanding of the carbon cost of a square foot. By the way, we look totally at operational implications. None of this has the carbon impact of the car, the building, the rail line itself, et cetera. We really were focusing on day in and day out operations. Next slide. The other implication is, as I've said, where you live and whether you need to heat or cool, the fact that you're reliant on a grid that's often, decades old, that is something that in the long term is a focus globally. Even in the great state of Texas, most of the time we're over 50% renewable energy, notwithstanding the politics of the place. But what it also talks about is human comfort and human safety. The reason we have to energize our buildings at all is because we insist on having lighting, thermal comfort, water that's heated occasionally, and water that's even delivered. The fact is, we're not in any of our research looking at creating substandard locations. It's how do we accommodate quality environments for all in a city, defined as the outline of a city defined by its jurisdiction. Next slide. Perhaps the most important element is the choice of when I'm not there, let's not use the resources. This comes under a concept we call the tyranny of choice. We want everything on at all time, just in case, which is great, except that implies some resource implications. During COVID, in the transition, offices were open, hoping people would come back. People were staying at home. The third places were saying, we still need to stay in business. Come work here with special spacing. So at any given time, you had 3 or 4 places you could work, and they were all fully operating. The analogy in my life, and this is the fun situation, given the city of Houston off-street parking codes, any place in Houston has, for me, 20 parking spaces in case I'd like to multiply myself by 20. Just for convenience, with off-street parking, I have 30 spaces, 20 to 30 spaces. Well, we have to avoid that in how we operate our buildings. That does not need to be the reality of our resource use. Next slide. And back to the commute. I mean, clearly that's a focus on many fronts. What we found in our research, it wasn't a knee-jerk reaction that by eliminating commute, we had less carbon impact to workplace. It's a really complicated mix. As some have pointed out, we were still driving all over, not commuting when we weren't in the office. We were running errands. We recognize that. Clearly the implication, though, of better choices for the longer commute, not being in your pickup truck dually in Texas, is a really important facet. If we look at a city and a corporation's focus on their collective impact, how to encourage, as many energy companies in Texas do, electric vans, van pooling, carpooling. It's already in the mix for both traffic control, but now we think more on this carbon conversation. And because we're designers, you can see we are tackling, how do we make both the office space more effective and efficient, perhaps segmented in a way that if, an office space isn't used, we're not fully functioning. Some questions were clearly spot on in terms of when I'm in my house, I'm air conditioning the whole thing, but I don't have to have all the lights on. When I'm not in the house, there's a certain level of ... It's a design approach, but also, as we see in some parts of the world, it's a regulatory approach in terms of efficiencies, smart metering, or energy demand control. If there's a problem with the energy supply in Texas, more and more organizations have the efficiency to turn things off. I mean, we're looking at everyday workplace impacts, and we think it's a combination of design and potentially corporate policy that could assist in their, larger footprint reporting. Next slide. Bhuvan?
Yes, so I'm just going to share my screen. And so while that comes on, I mean, excellent comments in the chat, as Rives was pointing out. And we had like countless discussions on this, do we include the embodied carbon, EVs versus IC cars, EVs start off with a higher carbon from the factory, the carbon for, making your house, if it's an old stock, new stock, for office buildings, and for public transit systems, right? If it's heavy rail, then there's a lot of embodied carbon as well. But we mentioned, like this was, what can we do as a quick changes? And that's why we just, okay, let's look at operational for now, and maybe at a later stage include the embodied carbon, life cycle carbon of it. And again, many questions in the chat, a lot of people when I'm working from home, I'm in my small office and only that is conditioned. That is great if you can, if you have the ability to condition certain rooms and turn off other rooms, or if you're working at home, nobody else is there and you turn down everything. We know like there are a million different scenarios just in, across these 9 US cities. And that's why as we were working on this project, we felt it'll be helpful that if we just give folks, a sort of a calculator that, again, we had to reduce the number of options, because if we could just have like infinite number of permutations and combinations of this. So and we've shared this link and we can put it back in the chat. You can select, your city here. We have, these 9 cities. You can select, what type of house you live in, apartment and multifamily building or single family house. New versus old, typically any building after 1999 is considered as new. Rives, you can correct me if I'm wrong for the building code. Household size, if so if you're saying I'm alone in the house, it's only my office space. So you can make this one. You can make the size of your office, which could be like 500 square feet, and so simulate it for just your home office, right? And not the rest of your house. And then what type of heating is it? Electric heat pump, natural gas furnace, and is it always on? Reduce while at work. I have no control because there's somebody I need to take care of who's always at home. So that's all. I mean, that's always on, or sorry, in apartment buildings where we don't have control and the heating is always on, in like New York and many places. That's the option here. And then on the right side, you can choose your commute. So we'd have car, passenger, e-scooter, private car, electric and gasoline. We really wanted to make the, if somebody has a gas car with a gas car commute, and they cannot shift to public transit for so many reasons. If they want to just simulate like, hey, moving to a electric car, how much am I actually going to save operational carbon on a daily basis? You can select that and simulate that. Of course, if you can go to biking or public transit, that reduces it even more. And then here is the commute one way in miles and the number of days in office. You can set this to 0, if you're not working in the office. And then your office vintage, again, the same building code. And do you have an assigned office space? Sorry, do you have an assigned workstation? Is it an unassigned workstation, or is it an assigned office, closed door office, in which case your office space goes up? And what's the heating of the office? So yeah, you can play around with this. This is car, passenger. I can change this to public transit. And it may be a little slow because all of y'all are probably currently accessing it, but I think this is something that we felt might, and we'll probably keep updating this. I think there's a ton of feedback that we've got from the chat today that we'll just go through and see what quick fixes and upgrades we can make to this calculator. I think with that, I'll pass it to Jinua for comments and
great.
questions.
Yeah, this carbon footprint of the Workday is one of the most effective research that MIT Mobility have done. So I really thank to Rives, Jacob team at Gensler collaborating with Bhuvan, John to do this, right? So I take 2 major lessons from this research. The first one is the danger of everywhere, every time operation, as Rives just pointed out, right? I think there's a pursuit of this extreme flexibility. That's true for office. That's true for parking, as we mentioned. That's true for we want a computers, iPad, iPhone. We want multiple water bottles. That's really a danger that the whole industry pushing toward that direction, right? So where do we put the constraint on that, right? If we don't put the constraint, then the ecosystem will be the final constraint put on the human being as a whole. The second point is also learn that a narrow-minded optimization is dangerous. Here, meaning many of us are transportation professionals. We want to optimize transportation, reduce carbon transportation, right? So this project find that if you just define the organization within transportation domain, we may make a huge mistake at the price of making the whole urban system inefficient here, right? In fact, transportation system is here to enable a high level optimization of the urban system. So thank our Gensler colleagues, Rives and Jacobs here to really bring the discussion beyond transportation, but look at the broader urban system. Right. So I have a couple questions for Rives and Jacob particularly. Mostly I invite transportation expert. I don't have a lot of chance to have a building architecture expert here, so I'll take advantage of that. The first one is about the setback in the office side, right? Well, intuitively we notice that even say 1/3 people are in the office, the whole thing's on, right? So where we are purely in the technology side, where we can micromanage room by room, depending on where people are, to reduce setback without requiring everybody off the building.
Sure. So let me answer that. And again, I'm the architect of the team. Jacob is a fast learner and could probably answer quickly too. In fact, most modern buildings, and the question in the side, we consider modern anything after 2000. There was a major US, our focus at the moment, building code shift that really amped up the capacity of or the target of buildings' energy performance. Again, local codes, they vary. That's why climate and local code are as important as the grid. But to your very good point, Jean-Noir, the point is our office buildings, for the most part, are already organized to do 3 important things when they're not occupied. Number one, we know the light sensors, right? Things go down. If a floor, and we pioneered this way back with the New York Times building, almost by light fixture, we can turn off lights if there's nobody close by. Now, lighting is increasingly a smaller percentage of what is energy in our office buildings. Welcome LED lighting. Thank you. That's another 2,000. Yeah. Also, we have something called economizers, which are basically, if the building is empty and we sensor that through CO2 or other monitoring, we don't have to bring in as much outside oxygen. The phrase HVAC, heating, ventilating, and air conditioning, the ventilation is necessary to give us oxygen in our sealed building. outside could be really cold in Boston. We have to heat it, or in my part of the world, really hot and humid. And somebody said, why are the buildings in Houston so cold? Is because we have to dehumidify what's called our makeup air. If the building's empty, we don't bring in as much. And we can save a lot of energy for both heating and dehumidification. That's a big setback. And then the other thing, though it's minor, but as we get smarter and smarter with our buildings, it's getting more and more important. It's the plug loads. Your computers, your monitors, the stuff that shouldn't be on if you're not there now have setbacks or turnoffs. We even have plug strips with sensors that if you're not sitting at your desk, whoop, everything goes off. So we have in our office buildings far more automated processes than we often do in our houses with an Ecobee and whatever. I have a thermostat that sees if I'm there and it sets it back, even if I don't mess with setback. So we're seeing more of that in houses, perhaps even in lighting. But the reality is the technology for offices tends to be farther along because saving energy saves dollars, and our landlords like that.
Right. So a follow-up on that. So now we have the technology feasibility, but behaviorally, are we doing that?
No. That's our problem. And in fact, we have even in offices, people say, well, I'm going to be in this conference room for 2 hours on another floor. Why? They need to turn things on. Or we have conference rooms that shut off systems, and yet people are distressed when it, either it's not always on. Oh, I don't like seeing dark areas. We have clients that don't want dark areas in their offices or at home, back to the bother of turning it down, or to the bigger point you made, I want to be able to pop into my office for an hour and I want everything operating, and I want to go back home for the rest of the time. And I don't want to, it's that, once again, tyranny of convenience. That's our biggest situation that we think at the corporate scale, how do we incentivize or encourage better behavior?
Right. Another detailed question, just for the naivety.
Sure.
See, for example, this is my building.
Yes.
I forget which year, I lost the capacity to open the windows. I have no control of that, right? Tell us the rationale for that.
Well, that's an interesting comment, because as an owner for 10 years, I pushed back and actually built buildings with operable windows. So I will tell you, I'll be silly and then I'll be serious. Can you imagine we trust you to train our leaders of the future? And I was dealing with a medical center, but we don't trust you to know to close a window if it starts to rain. Our operating folks are convinced that their staff, their faculty, are idiots, right? And if you have the window open, humidity, water will come in, you'll lose the air conditioning, we'll spend more time. So we have to have a sealed building in theory to be energy smart, when in fact it's not right, because there's great times of the year you open the window and it's cool and you have a connection to the outside. And the windows I put in buildings weren't about natural ventilation, it was simply connecting to the nice day outside, right? And the fact is that makes you feel better. And if you can open that window, you're willing to have the building be a little warmer because I can modify it. So having modifiable, office space, lighting, a fan, the windows opening, you're more than happy to be a little bit warmer occasionally because you can do something about it, which in fact saves a lot more energy than a very tight set point. The other window issue that we're finding now is that when we have power outages and you're in a sealed building, and full of people, it's an issue with the quality of the air. And so we're seeing some folks thinking operable windows are necessary for the day, afternoon, whatever, where suddenly there's no mechanical system and I can open the window and get fresh air. So there's quite a balance of the discussion about operable windows in offices and academic buildings, et cetera. But it comes down to those office managers saying, I can't trust those people to close the window when they go home for the weekend.
Right. One question for Jacob. You mentioned the 150 square footage per person as kind of the industry standard there, right? And during COVID, there's a substantial pressure on the office market. Many people work at home, office is empty. Do you see the trend that a corporation is going to shrink that to even more, or is it stabilizing?
Well, it's certainly possible. Right now, we're seeing really a variance between 150 square feet and 250 square feet per person. For the purpose of the presentation, it was easier to just say it's one hard number, but it really is this larger variance that we use across our projects. Potentially, we could even be seeing the opposite of less densification. A lot of offices are really asking for more amenities right now, more amenity spaces, common spaces, quiet rooms, areas that are not your normal typical workstation. So we could very well be seeing actually a de-densification of office space, especially as some offices say, oh, people will work from home these days, other days. So we use this extra space for these amenity spaces. But it really does stand to be seen what will happen in the long term.
I see. Then on the home end, we mentioned this aggressive 60% home setback. So there are about half of the family, they just couldn't do that. People at home, still, etc. But let's talk about the people who can't, right? Who everybody left in home. And with the technology to do that, is it similar to the corporation side that even though we have technology, but people just don't do it, right? And if, and also any other policy or incentive we can motivate people to actually do that?
Well, I think there's an immediate economic incentive to doing it. If you tell people, hey, if you use less energy during the day, you're going to save money. You have lower electrical bills. So there is a built-in economic incentive to this at the start. But of course, you have to have the behavioral nudge, which is difficult to get across. Something that I saw someone note in the chat, which is important, someone mentioned pipes freezing. That's why we have this at a 60% level. You can never reduce your home energy use by 100%. Otherwise, all the food in your fridge would go bad. All your pipes would freeze depending on the season. It could be a mess. So we do limit it to the 60% setback.
So let me jump in real quick.
Yeah.
Please.
This is a very good point, and we're very much all over this. Every place is a workplace, whether you're at Walmart, whether you're working in a hospital, whether you're working at the airport. We approach every place we design. There's invariably somebody doing work. And to be gentle, we do a lot of work with Walmart. We not only are doing their corporate headquarters in Bentonville, bringing a lot of this to fore, but we're working with them at some of their, without going into detail, standards in the workplace. And so the idea is never, ever, ever that we should be saving carbon and saving energy to the uncomfortableness, the unsafetiness, the unhealthfulness of anybody doing it.
No.
But we waste a lot in any workplace, whether it's overlighting or lighting the wrong thing, or thermal comfort can be done in a way other than blowing a bunch of cold air and hoping it fills a big box. But the comments on the right are just so spot on. It's a fine tuning in the workplace. Yes, Walmart folks don't get to work from home. They're unloading things. The hospital nurses are not working from home. But it behooves us to make sure they have an incentive that while they're at work, they can save their very hard-earned cash at home, whether it's an apartment or whatever with their family there. We think there's ways that you make a choice where to work, and if the home is empty, apartment is empty, let's encourage energy savings, as Jacob just said, no matter where you are, where you're not having to be.
Right. And we do recognize there is some limitation to this. Not everyone can turn down every aspect. Myself, for example, I live in a multifamily building in New York City where I can't affect my heating. The heating comes on when it's decided, and then that's the end of the story. But wherever you can affect your energy use, that is a place where you should be taking some level of action to reduce your own expenditures and also to reduce carbon emissions on a global scale.
Yeah. Last comment from me on the pass to John here. That is, I noticed something like more of a symbolic gesture. So, for example, people will say, "Oh, I turned off the light, right? Did my part, right?" But as Rives mentioned, the light is actually smaller part of the consumption. So there is an education piece that let people understand what's the big chunk of the energy where you can do something meaningfully on this, right? To you, John.
Okay, super. Well, as you all see, lots and lots of commentary in the chat.
Yeah.
Let me just open with, there were quite a few comments about working from home versus return to office. And I should emphasize that was not really the goal of this study, to answer one is right or the other is not. I mean, really thoughtful questions. Ellen Partridge said working, excuse me, working at the office also requires additional costs for commute, lunch, additional hours for childcare. I mean, this is huge. That was not the question that we were seeking to answer with this work. It was really about the carbon footprint of the full commute day. So I just wanted to sort of get that out there, but thank you to everybody for the comments about the slings and arrows of working from home versus working at the office. There were also quite a few comments and questions about the definition of the city. And Bhuvan, you did mention this, but I think that's worth sharing. So how are we defining city boundaries? Where did we place, why don't you just share that? How did we define the city boundary in this study?
Yeah, so initially we started looking at the core-based statistical area for these, metros. So that's, if you look at Boston, that goes all the way, up till, I don't know, north of Concord in New Hampshire and, New Bedford. And in New York, it was going into some farmland in Pennsylvania. So, we're like, okay, this is getting too ridiculous. So then we made a tweak. We selected the census city boundaries with trips originating to and from it. So people could be coming from a suburb or an exurb, but they were coming, into the city to commute and then going back for that. So that gave us, much sharper insights, and it still included a lot of trips from outside the metro, the city geography.
So one mechanic to add to that, which is the hidden element, for us to do the energy modeling to identify what's called the energy use intensity, kBTU per square foot per year, that gives us our carbon footprint by virtue of the grid, it's driven by primarily a city building code. Often what keeps us from doing this globally is the fact that many places like Mexico City have no universal city energy code. So there's no way to guess what the actual use of the newer buildings. Now, the reason we did newer is because older buildings, who knows when they're built and how energy profligate they are. We had, frankly, with our Boston colleagues, lots of debate. Well, electric versus natural gas heating. We kept it all electric. We made it really simple. Natural gas has some kBTU advantage, but not carbon advantage. We kept it all electric, 2000 or newer buildings, multifamily, single family, and office. And by the way, we did more research about other spaces. Food and beverage, the lunchtime is hugely carbon intensive. It's better to eat lunch at home than to eat lunch at a McDonald's at the office, by the way. So, but that wasn't in our research, as John noted.
Super. Okay. Antonio Paiva had a question. These discussions seem always focused on big cities like New York. A lot of people live and companies have campuses in suburban areas. How do these studies apply, if at all, to those people? Maybe, Bhuvan, do you want to just answer from the commuting side and over to Rives and Jacob for the office side?
Yeah, I mean, from the commute side, these 9 cities all have some sort of, public transit agency, or maybe even a light rail line running through it. I mean, if you keep, New York, Boston, San Francisco, Chicago, LA apart, that have a decent public transit network. So, I mean, like I said, we said the list kept going up. We started with 3 cities, then 5 cities, then it went up to 9. And, I heard people in the chat saying Seattle should be added. So, I mean, these are all great suggestions, and we will, keep it in mind for, future work. But yes, that's a great point. In like smaller tier 2 and tier 3 towns and villages, how do people commute? It's mostly car, obviously. It's lesser of, bus commute, and obviously no light rail or heavy rail. So.
And in terms of suburban versus rural, et cetera, our calculation is total climate based and total energy grid based. There's a variety of sources to find out where you live and what's the mix of coal, natural gas, renewable, anywhere in North America, US. We also have sources now pretty globally, but for maybe the global south is still spotty. Our calculation is new buildings, and that office space is ubiquitous. That is, no matter where it is, we know the energy demand with the climate, and then you connect it to the grid. So we could apply this anywhere, and it's the commute nuances that Bhuvan has noted, I think, is the big difference.
Excellent. Okay. Back to Jacob and Rives. So Chester Harvey had a question that he preceded with a comment. So he said, I find the lack of scenarios where the office has a setback realistic but disappointing. My office seems intent on being cooled and heated as much as possible, no matter how many people are in it. So the question is, are we letting the office side of this equation off the hook? What about the behavior of the office manager?
Yeah.
So just occupancy sensing. Robin Chase also noted there's a company that sort of a startup sensing where people are in the building. Tell us more about that.
So there's a whole world of AI, what's called the digital twin. The point is we're knowing the office buildings, it behooves them to save energy. And yes, by the way, the competition to get people into offices, the grade Bs and Cs, we're seeing a lot of movement there where they're improving the indoor environment, they're creating amenities, they're encouraging folks at less expense per square foot to take more square feet because amenities count. So there's a definite demand to make a better work environment, which includes indoor air quality, fresher air, which by its nature takes up more energy because you're bringing in more fresh air. So we see a lot in our world of mechanical system, lighting system improvements that, John, you mentioned, this colleague said. The big point is where people collaborate together, who calls the shots, what the temperature is, and what the lighting level is. And so the personification, as I mentioned earlier, which is your individual work table spot, you make work for you through a task light, through perhaps raised floor ventilation where you can reach down and change the ventilation, not the temperature. You open or close a window, as Gensler was saying. We think personification will make it better for you if indeed we take a slightly cooler, slightly warmer time of year and lower lighting. Overhead lighting is less important than the task lighting. So we see in office design a rush toward optimization, but personalization. That's the future. And the fact that buildings now can learn from the past year of how they operate to predict and move forward and modify things to optimize continually. I mean, that's how my new Ecobee thermostat works at home. We see a lot of that happening. And it behooves them. Again, it saves money. It's an attractor for new tenants. And, frankly, investors and insurers are all but requiring this kind of thinking.
Super. Stephanie Pollock had, I think, a very interesting question, which is, does this project take into account additional non-commute trips taken during the workday, but people working from home? There's data that home workers make additional non-commute trips while they're working from home. Now, of course, immediately we have to ask, are those non-commute trips while they're working from home trips that they otherwise would have taken when they weren't working from home or during the non-work day? So is this a substitution effect? Any reflections on that? Maybe I'll start with you, Bhuvan.
Yeah, I mean, again, I think we had a lot of discussions on this. A lot of variance because some people on the way back from work pick up, that carton of milk and then reach home. So it's not really a detour. But if you're working from home, you may have to, in a not so dense neighborhood, take your car out, drive those 2 miles, and pick up the carton of milk. So if that's why we made the calculator. If you're actually working from home all 5 days, but still making 3 trips, 3 days of these 2 mile one-way trips, you can just add it into the calculator and figure out, okay, I'm still saving carbon even though I'm going to the supermarket 3 times a week instead of going to the office 5 times a week. So yeah.
I think the question exposes the complexity of
Yes.
we had to make many assumptions. I do hope that one of the key takeaways is what Rives emphasized, that it really depends where you are. Houston, the situation is a lot different than it is in San Francisco.
Yeah.
So turn it back to you, Gensler.
Sure. Yeah, indeed, the point of a commuting trip reduced through the work from home, but the total travel didn't. In fact, the Texas Mobility Report reported this year, U.S. cities reached the worst ever congestion since that data series started in 1987. So that's a much bigger set of a problem that beyond the commuting itself there, right? Yeah. So I really appreciate this work, the collaboration between Gensler and MIT Mobility Initiative. Let's do more of that. Thank you, Riv, Jacob, in this. Everybody, please join me. Thank the whole panel, Bhuvan, John, for this presentation and conversation today.